Start from Program Setting to handle large data. Go to Option, Program Settings, then open the Input and Output and check Binary and Uncompression boxes. Next, import the CAD file by dragging and dropping it into the drawing window. After a moment, the Location of Import Part dialog will appear. Click Place to continue. We will create a cuboid part and set the individual mesh settings later. Click on Cuboid in the toolbar and set the part name to Find Region. Then enter the location and size parameters to encompass the engine. Next, let's check the overall conditions, starting with the fan model. The radiator is equipped with 2 fans, each having a different flow rate. Now, open the condition wizard and review the other conditions. For the analysis type, flow, heat, and radiation with the flux method are selected. Then proceed to the basic settings where gravity is set to the negative z direction. For the inlet condition, a fixed velocity condition is applied to the x minimum boundary, and a static pressure condition is applied to the x maximum boundary. Move to the wall condition. A free slip condition is set for the side and top boundaries. For the bottom boundary, a translating wall condition is applied. For the other walls, they are set to no slip condition. Next, we apply the condition of volumetric pressure loss to the core of the radiator. Then we move on to fixed condition, where the engine block is set to a temperature of 90 degrees Celsius. Next, we configure the radiation settings. The air is treated as a radiation field, while the other solid materials are assigned with an emissivity of 0.9. In the analysis control settings, we set the maximum cycle number to 500. The convergence criteria for both flow and temperature are specified to 1e-5. Next, Let's explore the partial FLD output settings. This feature is particularly useful for examining specific regions during post-processing, especially when dealing with large datasets. Open Partial FLD tab and check Output Partial FLD. Then, click Plane button and set the output interval and position of the plane to output. Select the Add button to register the condition. Open Mesh and Gridding in the menu bar. Select Not Considered for the vertex detection. Then enter 10 mm into the XYZ coordinate of the standard length field. Then open the Parameters tab and double-click on the Find Regions part in the list. A dialog box will appear where you can input the number of divisions. In this case, the values are set to ensure that the mesh length is 5 mm. Click Set button to close the dialog, and then press the Grid button. In just a moment, a rough grid will be created. Next, click the Meshing button to run the meshing process. When dealing with numerous parts, this procedure serves as an effective example for creating a fine mesh in specified regions while optimizing the overall data size. Now, let's move on to the solver execution process. Launch scMonitor and drag and drop the S file into the interface. Then, click the Execute button to start the process. Finally, let's explore the post-processing stage. Drag and drop the partial FLD file into SEPost. Select the plane object in the tree, then open the Contour tab and check the Display option. Set the temperature as the variable. To adjust the color bar range, select Color bar for temperature only in the tree. Open the Range tab and set the minimum and maximum values to 20 and 30 respectively.